Hello everyone, we are from UTM Faculty of Electrical Engineering, and this is our course SEEE-3533 Communication Principle, and we are from Section 3, Group 6, and here is our video presentation about the mission 4, and my name is Ericsson, and here is our group mate, Oscar Chan Yun Pin, Ibn Chuan, Vincent Lim Chiu Sin, and Muhammad Nur Izzuddin. And what is communication principle? Actually, communication principle exists around us. Do you guys ever wondering how our voice can be transmitted through a phone to our maybe far away of friend's phone, right? And how the data can be transmitted? I believe you guys have heard about FM 36.5, FM 37.6, about the radio station, and what is meant by FM, and how the radio station can transmit the information through the air to our car or our radio, and how our radio can be catch the information and transmit to the information that we want to listen to. So in this presentation, we're going to discuss about the baud rate and the bit rate and modulation. So what is modulation? Modulation actually is a process of converting the data into radio wave and adding the information into an electronic or optical carrier. So it's just like our voice. Our voice, when we're talking, we will transfer into the electronic signal, and the electronic signal is our data. And the data will be adding into the radio wave. And the radio wave, we call it as carrier. So it's just like a car, poo-poo, then we add the information inside, and you bring the information and travel very far away to our phone or to our destination and extract out the data and do the information that we want. And that is modulation.
And we have several types of modulations. For example, we modulate through amplitudes, we modulate the frequency, the phase, and we have quadrature phase shift keying and quadrature amplitude modulations. So the next concept we need to know is the baud and bit rates. And baud is basically how many times a signal can change per second, and the bit rate is how many bits can be sent per unit times. And usually we calculate it per second. And from this picture we can see the difference between the bauds and the bit rates. And basically we can clearly see that the bit rate is actually affected by the bauds and the number of signal level. So next, Oscar will introduce us the concept of amplitude modulations. So that's all from me. Thank you.
Now, let me explain to you furthermore regarding for the amplitude modulation. As you all know that modulation is the process of shifting the frequency of original information signal from low frequency to high frequency using the carrier signal. So, what does amplitude modulation works? So the purpose of amplitude modulation is to change in the amplitudes of the carrier signal according to the information signal. As you can see on these diagrams, we're using the carrier signals and the message signal and pass through the balance modulator in order to produce a new signal by going to undergo the amplitude modulation. So these are the equations in order to generate the amplitude modulation by combining the Vm, which is the message signal, and the carrier signal together in order to produce these equations with the help of the modulation index. So how does amplitude modulation works? Let me explain to you. So this is the message signal that we want to transmit. For example, we can transmit the message signal in the cosine graph. And in the carrier signal, these carrier signal are also in terms of the cosine graph. And how does the amplitude modulation works? So imagine this is the signal comes from the message signal, and it changing the amplitude of the carrier signal. So as you can see that the amplitude of the carrier signal is getting larger, but at a peak point it will getting smaller back again. So in this results showing that this is the new waveform formed from the amplitude modulation signal.
Next, we go to the frequency modulation. So what is the frequency modulation? Frequency modulation, or FM, is produced when the instantaneous angular frequency of carrier signal is varied linearly according to modulating signal. It uses the message signal where VMT to vary the carrier frequency within some small range about its original value. FM has a higher signal to noise ratio compared to AM, which means amplitude modulation, which is more immune to noise by the receiver. So based on the picture on the slide, this is a generation of frequency modulation. So we want to get the frequency modulation signal. We need to integrate from the message signal where VMT. Let's go to PM modulator. For your information, duration of FM name PM modulator. So we get the frequency modulation. So next, this is explain more about generation of frequency modulation, where this is a general equation of frequency modulation, where EC stands for carrier signal, cos omega C stands for angular frequency carrier, T plus KF integrate VMT dt. VMT stands for message signal. Beta stands for modulation index, where beta equal to KF EM over omega M and equal to delta F over FM. Delta F means frequency deviation over modulating frequency signal. So next, this is FM signal in time domain.
Hi everyone, my name is Wenjuan. So today I will share with you what is the path modulation and path demodulation. So in path modulation, the instantaneous amplitude of the baseband signal will modify the phase of the carrier signal, keeping its amplitude and the frequency constant. So the phase of a carrier signal is well modulated to follow the changing signal level with the amplitude of the measured signal. So the trend of the data will be represented by the phase change. So let's see an example. So for this example, we can see when they data change from 1 to 0 or 0 to 1, we can change the phase of the signal wave by 180 degrees, which is the one big signal. So and when there is no data change, for example 0 to 0 or 1 to 1, so the signal will hold very continuously. So this is the path modulation. So what is the path demodulation? Actually, this is a same concept. So first, we detect the phase changing. If the signal wave is very smooth, there will no phase change. If no smooth, they will got a phase change. So when got a phase change, so we detected the phase change. The data will change from the original step to the opposite step, which is like this question example. So just now is original step is 1, so he will change to the 0. So for example, this is the no phase change. So he will step at its original step. For example, now he will step at 0. So the original step is 0. So he will step also at the 0. So that's all for my part. Thank you.
Hi, it's me again. So I'm going to explain about the quadrature phase shifting keying, or we call it as QPSK, or quadrature amplitude modulation, QAM. So actually, what is QPSK? So I believe you guys listened to the Wenchuan presentation, so you guys know that the data can be represented by the phase shifting, right? So it's either 1 and 0. So here, for the QPSK, it transformed to maybe a spot card. We can carry 2 bit. So maybe it can carry 0, 0, 0, 1, 1, 0, and 1, 1. And all the data can be transmitted at one time. So it becomes more efficient. So we introduce this QPSK. So the QPSK will be represented by the angle. So maybe the 45 angle is 0, 0, and 135 angle is 0, 1, 315 angle is 10, 1, 0, or 225 angle is 1, 1. So we take the data out. It's here. It's like 45 degrees. So it's similar here, 45 degrees. So it represents 0, 0. Same goes as here, 135. So it represent 0, 1. And it represent 1, 0. And represent by 1, 1. So every single difference of the angle will represent different type of the data. So let me introduce one more, the quadrature amplitude modulation. So what is QAM? Actually, QAM is an upgrade version of the QPSK. Can carry more bit than QPSK. So for just now, the QPSK is just like a car. They can carry 2 bits at one time. So this QAM kit can represent by the bus. It can carry 3 bit, 4 bit, and 5 bit. The increase of 1 bit will represent 2 power of the bit data. So you see, at this angle, at this point, is 45 angle, 45 degree. So you can see it's represented by 2 data. How are we going to differentiate? We use amplitude. Small amplitude will represent the small data here, the small circle here, and the higher amplitude will represent the larger one. And that's all for us. Thank you very much. I hope you enjoyed this video, and the link below here is a game. So you can use this knowledge to play this game, to complete it, to apply our knowledge. And thank you very much, and hope you can enjoy this video and learn something new. Last but not least, and please fill the Google form at the below as a feedback to us. And your feedback is for us is very important. Thank you. Bye bye. See you again.